All right, so for this lesson, we have two objectives: to be able to calculate and display marginal and conditional distributions from a two-way table, and determine if an association could exist between those two variables. So that might not make any sense right now, but once we get into the lesson, you'll start seeing that play out. So go ahead and write your objectives in your notes. So by the end of this lesson, you will be able to do the following things. You're going to be given some data that was collected from last year's stats class, and it's broken down by Algebra 2 grade, so A, B, C, D, and whether or not their parents went to college or didn't go to college. So instead of just looking at grades, A, B, C, D, it's then how many students who got A's had parents that didn't go to college that did go to college. And so you're going to have to answer a variety of questions based upon that data and then make a decision about whether or not an association exists between a person going to college and how that impacts his or her child based off of the sample. All right, so what do you think? Do you think that parental smoking influenced the smoking habits of their high school children? So if one or both of my parents smoke, is that going to impact whether or not I smoke? Or on the flip of that, if my parents don't smoke, is that going to impact my choice about smoking? So the amount of vocabulary today is pretty minimal. We have 4 vocabulary words, a two-way table, marginal distribution, conditional distribution, and then association. All right, so we're going to start with marginal distribution. So that same question, does parental smoking influence the smoking habits of their high school children? And so here is a two-way table that was collected from a number of high school students, and they were asked about whether or not their parents smoked. So what's happening in this table is that I surveyed 5,375 people, and it broke down that 1,004 of the students did smoke and 4,371 did not smoke. So when I add those two numbers together, everybody who I surveyed fell into yes, I smoke or no, I don't. But then also, this 5,375 were then also asked the question, do both my parents smoke? So 1,780 did. One parent smokes, 2,239, or neither parent smokes, 1,356. So all of those three numbers added up give me this 5,375. And I can see then in the table, okay, 400 students smoke and both their parents smoke. 1,380 students do not smoke when both their parents smoke. So that's how we read this two-way table. So a two-way table is a table that organizes two pieces of categorical data about the same individual. So this 400 represents 400 students who fell into both of those categories. So this is going to be two pieces of categorical data, so it's bivariate data. Marginal distribution is we're talking about row and column totals. So these are my rows and these are my columns. So I have my totals, but we're going to compare it to the overall total in order to have a marginal distribution. So we're going to come up with a percent. So essentially, I'm going to come up with what percent of students smoke, what percent of students don't smoke, what percent of students have both parents that smoke, what percent have one that smokes, and neither. So what we're going to do is we're going to go through the process of finding those percentages. And so if we're comparing to the overall total, so marginal, I always think of marginal as I'm in the margins. So I'm not calculating in the table, I'm calculating in the margins. And so we're comparing everything to the overall total, which is 5,375. So in order to find the marginal distribution, I just have some guiding questions that can kind of walk you through that process. So when we're doing marginal, we're always talking about just one variable at a time. So I don't care if I'm thinking about does the student smoke or does the student not smoke. I don't care about what their parents' decisions are and vice versa. So marginal is always just that one variable at a time. So the first question is, what is the overall total of the table? And we can see here that everything is out of 5,375 people. So I'm looking at how do those 5,375 people fall into one of the variables. So what percent of the overall total is each row? So when I'm talking about rows, I'm talking about these numbers right here. And so I'm looking at, when I'm talking about rows, my variable is whether or not their parents smoke and how many of their parents smoke. So I'm thinking, what percentage of students have both parents that smoke, one parent that smokes, or neither? So I'm simply going to take these values and divide them by that 5375 to see how that breaks down. So I'm only looking at one variable at a time. So I'm going to do 1,780 divided by 5375, and I get 33.17%. All right, and then I'm going to do 2239 divided by 5375, and I get 41.66%. And then lastly, I'm going to do 1,356 divided by 5375, and I get 25.23%. So since I'm only looking at that one variable about their parental smoking, these numbers should, in theory, add up to 100% because I've taken that 5,375 people and I've put them into just one category. So when I do 33.17 plus 41.66 plus 25.23, I get 100.06, which is going to be a rounding error. As long as I'm within a tenth of a point of 100, I should be fine. It's just a rounding error. Alright, so go ahead and pause the video and come up with the marginal distribution for the variable about the student, whether or not the student smokes. So go ahead and calculate those column totals. So hopefully you were able to come up with 18.68% of these high school students do smoke and 81.32% do not smoke. And when I add those together, 18.68 plus 81.32, I get 100%. So every one of those 5,375 students fell into one of those two categories, so we're talking about 100% of the students. So these are the questions that I basically went through. What is the overall total? Because marginal is always comparing one variable to the total. And then what percent in each row, what percent in each column, and then do they add up to 100 is just my check. So that is marginal distribution. So our objective is not only to calculate, but also to display marginal and conditional distribution from a two-way table. So I'm going to take this information and I'm going to make a bar graph. So I'm just going to choose one of the two because we're just practicing bar graphs. It doesn't matter. I'm going to choose whether the parents smoke. So that's going to be my label for my x-axis. All right, and then we're talking about percentages. So we're talking about what percent of they fall into each category. So my y-axis is going to be percent, going up to probably about 50% because I have a 41%, well 42 if you round to the nearest whole percent. All right, so I've got my percentages up to about 50, and now I'm just going to graph my data. All right, so that's about a rough sketch of that marginal distribution of whether or not parents smoke. All right, so we have calculated and displayed marginal distribution from a two-way table. So go ahead and pause the video and have an interaction. So what do you understand? What do you need to remember when you go to take a test? Because this is going to be your study guide where you're going to pull that information from. Is there a visual that will help you understand or remember it? And then do you have any questions? All right, so marginal distribution is pretty straightforward. Conditional is where it gets a little bit trickier. So conditional distribution is we're going to lock into one variable and see how the other variable breaks down within that one variable. All right, so when I think through the process of calculating conditional distribution, I have three questions that kind of guide me. So what is the explanatory variable being explored? So in this case, I have two variables. I have does the student smoke or not? And then what are the smoking habits of their parent? So with conditional distribution, it can go one of two ways, and your problem or whatever you're working on will tell you which condition to focus on. So we're actually going to calculate both ways, but normally you'll just have one specific condition and then you'll calculate. And I will show you what that looks like in a little bit. So what is the explanatory variable being explored? And you would highlight that. And then what is the total of that row or column? That's your conditional total. And then what percent of the conditional total is each variable in that row or column. And so when I say row or column, you're locking into one of those depending on what your question is asking of you. So let's go ahead and just calculate one of the conditions and then we'll do the other. So like I said, you have two variables, whether or not the student smokes and whether or not the parent smokes. So let's start with whether or not the student smokes. Okay, so we're saying, all right, based on the condition that the student says, yes, I smoke, what are the habits of those students' parents? So when I look at this, I don't care about the students who don't smoke right now because the condition is, does the student smoke? Yes. So I'm talking about these 1,004 students. How do they break down? So both parents smoke. 400 of those 1,004 do smoke. Their parents smoke. So I'm going to do 400 divided by 1,004, and I get 39.84. So of the students who smoke, 39.84 of them have parents who also both parents smoke. So then one parent smokes. So of the 1,004 students who do smoke, 416 have parents that have one parent that smokes. So 416 divided by 1,004, and I get 41.43%. And then lastly, 188 fell into the neither of my parents smoke of the students who do smoke. So of 1,004, and I get 18.73%. So that's the conditional distribution of students who do smoke and how their parents behave. So I want you to pause the video and come up with the conditional distribution of parent behaviors based on the students who do not smoke. So you'll be talking about each one of these students based on the 4,371 students who don't smoke. So hopefully you were able to get that 31.57 of the students who don't smoke have parents who both smoke. 41.71% of the students who do not smoke have one parent that smokes, and then 26.72% of the students who do not smoke, neither of their parents smoke. And when I add those all up, the 3157, 4171, 2672, they should equal 100 because I took these 4371 kids and I looked at how do they break down within this. So I'm still talking about 100% of the students who don't smoke. So what if I'm asked to analyze on the condition of the parents' choices? So instead of starting with the condition of the student's choice, I'm looking at the parent's choice. So when I have a parent who just one parent smokes, what percent of students smoke of their child and what percent do not? So we're going to go ahead and calculate the condition on the other side of that. You won't be asked to calculate both conditions necessarily. It will tell you specifically which condition to calculate, but right now we're just practicing. So go ahead and pause the video and redraw your table down here. All right, so now we're talking about the parental behaviors. So that's our condition. So we're talking about 1,780 students, 2,239 students, and then 1,356 students. So once we lock into a specific condition, so like both parents smoke, I don't care about all the other kids until I start calculating theirs. So go ahead and pause the video and see if you can come up with the conditional distribution based off of parent choices. So fill out this entire table. All right, so hopefully you were able to get these values for the breakdown. So I took 400 divided by 1,780, and that gave me that 22.47, and then 77.53% of students who had parents that both smoked did not smoke themselves. So go ahead and check your values, and if you didn't get those or you have any questions, make sure you write that down. So in this one, we're going to do a conditional distribution bar chart based off of the condition of parent smoking habits. So we're going to use that second set of data that we came up with. So our explanatory variable is parent smoking habits. So that goes on the x-axis. And the three situations are both, one, or neither. And then the bars are going to be measured in percentages, and my highest percent is 86%. So I'm going to need to go up probably to 90 or 100%. All right, so both parents who smoke, 22.47 they smoked, and 77.53 said they did not smoke. So within this category of both parents smoking, I have two responses. So I'm going to have two different bars so that I can compare the two. So I'm going to, in red, it doesn't matter, I'm going to do the 22.47, who said that they themselves smoke. And then I'm going to do in blue the 77.53% who said they do not. So this is the no, and this is the yes. So what I can see here is that if your parent smokes, there are more people who said they themselves don't smoke. So now let's look at one and then neither. So go ahead and pause the video and see if you can come up with the two bars that would represent each of those conditions. So it's not perfect because this is hard to draw on, but essentially your bar graph should look something similar to this. So I can see that there is a slight trend in an increase of no's as I move from both to one to neither, and a decrease in yeses as I move from both to one to neither. They still have basically the same, there's still more people who say they don't smoke, percentage-wise, than who do, but I can definitely see kind of a reverse or an inverse trend. All right, so pause the video and you're going to have an interaction. So we have calculated and displayed both marginal and conditional distribution from a two-way table. So conditional is a little more intensive than marginal, so make sure you write yourself some notes, some steps, whatever you're going to need to remember when you go to study for this test or for the final in December. This is where you're going to look. So what did we just talk about? What are you going to need to remember? What steps will help you? Do you need a visual? And then do you have any questions? So is there anything that we just did that's confusing? All right, so next we're going to talk about association. So association is basically when we know the value of one variable helps predict the value of the other. So is there a connection? We talk a lot about association when we talk about things like, does the amount of time you spend studying impact your grade? Is there an association there? So when we look at these two bar graphs, we're looking for, is there a difference between how the males responded and the females responded, or are they exactly the same? So when you look at this no association, if you notice, these are equally spread, so that means there is no association. It doesn't matter if you're male or female in this graph. Your opinion, your gender doesn't impact your opinion. There's not an association. Whereas over here, if you notice, the green is a little smaller for the males, the yellow's about the same, the orange is bigger for the males, and the purple is bigger for the males. So this indicates, because there is a difference in opinions between the males and females, that indicates there could be an association. So there's a couple of ways to think about association, and you can compare association by comparing it to the marginal distribution. So if there's a difference between the conditional and the marginal distribution, that could indicate that there's an association. Or like that other graph showed, if you compare based on the two genders, their opinions, and there was no difference, or there was a difference, then that would indicate association. So when I look at this, so student who smokes, 18.68% of students smoked. So we're saying that it shouldn't matter, if there's no association, then it shouldn't matter whether or not the parents smoke. So all of those categories should be close to 18.68. But when you notice, the more parents that smoke in the house, that percentage went up, or the less, it went down. So there's an indication that there might be an association, because these would all be about 18.68% if there was no association. Likewise, we said 81.32% of students do not smoke, whereas over here we see that these numbers are high, but the likelihood of a student who has both parents as a smoker, their percentage of not smoking is lower than this, and then those who had neither parent smoke is higher than this. So the fact that those are different indicates that there might be an association between whether or not your parents smoke and your likelihood of smoking. All right, so we now have talked about association. I don't want you to stress too much about association. We're going to talk more about it. But essentially, we're just looking at how can we use the data in a two-way table to determine if there might be a difference. We'll talk more about that tomorrow, so don't stress too much. But go ahead and interact and think about what makes sense to you. What questions do you still have? And here are your definitions.